Okay, so today we're going to talk about hyperbola. And if you look at the equation, hyperbola the equation looks a lot like the equation for the ellipse, but notice that it's subtraction and subtraction. It still has to equal 1, and there are two kinds because subtraction is not commutative. I can't just put it in any order I want. So putting them in different order gives me two different kinds of hyperbola. The first one is called a vertical hyperbola, and that is if the hyperbola, which are two parabola, one back to back. That's the definition of a hyperbola, it's like two parabola back to back. A vertical hyperbola opens up and down. So here we got vertical hyperbola. And a horizontal hyperbola opens left and right. Okay? And you can tell by the equation which one is which because a vertical hyperbola will start with my y squared. Okay? So it's y minus k squared and x minus h squared, and the y minus k comes first. Then in my horizontal hyperbola, the x comes first. So it's x minus h squared first, then y minus k. And again, it's subtraction, so it's not commutative. But you'll notice that the a and the b stay in the same order. Okay? So it doesn't matter which comes first, the y or the x, the a is always going to be first. And that's what that guy's thinking. A is always on the left. It's always going to come first. All right? So when we graph a parabola, basically our job is to find these two dotted lines here, find out where they cross, and then we're going to find a vertex for our parabolas and then kind of sketch them so they fall between those dotted lines. All right? So let's practice that. All right, so to talk a little bit about like the pieces of a hyperbola, first of all, there's a center, HK, just like every other thing we studied, ellipses and circles and everything. The center is HK, but in a hyperbola, the center is not actually on the hyperbola because there's two of them. So the center is between them. So in this hyperbola, the center is right there, and in this hyperbola over here, the center is right there. All right? And then we have what we call the transverse and conjugate axes, which we're going to talk about in a minute. So hold on to those. It's not hard. It just has an ugly name. All right. And now we have parabola. So if we have parabola, we got to have vertices to do that, to graph them. And it's easy to find the vertices of a hyperbola because you don't have to do the negative b over 2a and all that stuff. It's just whatever. If it's a vertical hyperbola, which means it opens up and down, then the h, the center, is going to be the same as the first coordinate is going to be the same as the center, and then k, the second coordinate, is going to be plus and minus the distance that a represents, so the square root of this a term here. Okay? And in a horizontal hyperbola, the k is going to stay the way it is from the center, and the h is going to be plus and minus a. Okay? And we're going to do an example of this. So just take a second, even if you want to ask the teacher to pause it for a second if you need time to write this stuff down. And then the asymptotes, and that's a word you're going to hear a ton in pre-calculus, a ton in calculus. Asymptotes are lines that the parabola, or really any shape, but for in our purposes today, just parabolas. The parabolas are going to get closer and closer to them, but they're never going to actually touch them. They repel the parabola. So they're going to get closer and closer to the parabola. They're going to try to touch it, but they're never going to. Okay? And those are, the asymptotes are these two dotted lines here and here, and these two blue dotted lines here and here. Okay, those are called the asymptotes. And you'll notice that in the graph, you're getting, the parabolas are getting closer and closer to those dotted lines, but they're never actually touching them. Okay, now when we go to graph the axes, it's going to take care of the slope for us, but it's good to know the slope of the vertical asymptotes are going to be A over B, positive and negative, because they go two different ways, right? One goes down left to right, one goes up left to right, so one's positive, one's negative. But it's A over B. And for horizontal asymptotes, it's B over A. And again, this is going to kind of work itself out. You're not going to have to actually calculate the slope. So let's practice graphing. All right, so the first thing I want to do is find the center of my parabola. Okay, now remember, just like with ellipses, it's got to be the x or y term and the x or y term, and then it has to equal 1, and there has to be a minus. So first of all, make sure it's in standard form, and this one is, so we're good. Okay, then I'm going to mark the center, and the center is HK. Now just be careful, because it starts with y, and y and k go together. So this one is k, and this one is h. So my center is -1 from here and 3 from there. So my center is -1, 3. So I go over -1, up 3, and there's my center. Okay? The second step says draw the transverse and conjugate axes. So this is the part where we have to talk about what a transverse and conjugate axis is. So the transverse axis is going to be the A, okay? And the A, again, remember, is always first, okay? It's always in the left-hand side, no matter if y is above it or x is above it. But once you see it, once you look at A here, you have to notice if there's a y or an x above it, because if there's a y above it, then we're going to be counting up and down along the y-axis. If there were an x here, we would be counting left and right. So in this case, there's a y above it, so this tells me that a squared is 16, so A is 4. So I'm going to count, just like I did for ellipses, I'm going to count up 4 and down 4, again because of the y that tells me up and down. So I'm going to count up 4, 2, 3, 4, and down 4, 1, 2, 3, 4. Okay, so the distance from here down to there is my transverse axis. Okay, now my conjugate axis is going to go the other way. Okay, so I'm going to use this number. It's below the x, so I know it's going to go left and right. And if this is b squared, b is going to be 3. So I'm going to go left 1, 2, 3, and right 1, 2, 3. Okay, and I can tell because it starts with y, okay, that it's going to be a vertical hyperbola, right? Because it starts with y. If it started with x, I know it would be a horizontal hyperbola. All right, so it starts, so I know it's going to be vertical. All right, let me just write that to remind us. And the way I tell is if it starts with Y, it's vertical. If it starts with X, it's horizontal. So because it's vertical, which means it opens up and down, the ends of my transverse axes are my vertices. So these two ends are automatically my vertices. I see I didn't have to calculate negative b over 2a or anything like that. I already have them. All right? And now what I'm going to do is use these 4 points to kind of draw in a rectangle that goes up to there and over and down and up. Okay? So what I basically drew in when I found the transverse and conjugate axes here were the midpoints of the sides of this rectangle. Okay? And the reason I want the to draw the rectangle in is because those asymptotes we talked about, those dotted lines from the graph at the beginning, they're going to go through the corners of my rectangle. So my asymptotes are going to start from this corner and go down to that corner. And they're going to start from over here, go through the center, and then come out that side. Okay? And those are going to be my asymptotes. And you'll notice, remember I said you're never going to have to calculate the slope? Well, remember we said the slope of a vertical hyperbola is going to be a over b. So I'm going to go up 4 and right 3. So if I go up 4 from the center, right, I go up 1, 2, 3, 4 over 1, 2, 3. So I'm at that corner. Or if I'm going to do the other, I go down 1, 2, 3, 4 and over 1, 2, 3. So I'm back at that corner again. So by connecting those corners, I'm automatically calculating their slope. All right, so now that I have my asymptotes and I know where my vertex is, I kind of draw my hyperbola in there so that it never touches the asymptotes, but it gets closer and closer and closer. And then I have one down here as well. Okay? And that's it. My last step, right, was sketch the parabola through the vertices and approaching the asymptotes but never touching. So I marked the center. I counted up and down and left and right to see where my midpoints of my rectangle were. I drew in the rectangle. Then I drew my asymptotes through the corners of the rectangle. Then I sketched the parabola through the vertices, which were the ends of my transverse axis, and sketched it so that it didn't quite touch the asymptotes. All right, now I have some practice problems. They're going to look really familiar. They're basically the ellipse problems, but now we're going to be using subtraction, but everything is going to appear just like it does here. All right? All right. Okay, so now I'm going to pass out the homework, and we're going to give it a shot. And you can ask the sub to back up or fast forward or listen to it again if you want, or pause it somewhere so you can copy down some notes if you need to. But I'll leave it right here.